Welcome to Los Angeles Data Platform User Group again. Thank you for joining us today. My name is Steve, and I'll be a moderator of this virtual meeting. I'll be joined by Yelena Bachman, who is going to take care of the T-shirt raffle. If this is your first time or you're trying to keep a track of our meetings, please visit our Eventbrite or Meetup, or you can send us an email directly, and this way you can get notified on any upcoming events. If you're on social media, there's plenty of social media touch points that we offer. You can follow us and see what are we doing on social media in terms of the user group. And just in case, if you don't know, we are less than 30 days away from our main event. It's a once-a-year event with multiple tracks, full day. It's free to attend. We're only charging for lunch if you don't bring your own lunch. And it's on June 10th, and it's in Loyola Marymount University, the 1 LMU Drive. Just to make sure, because there is Playa Vista Drive, there is a Westminster something campus. So the 1 LMU Drive, that's the one location. That's the right location. And you can click on the URL to sign up, or you can click on Linktree that will take you to all the touch points as well, including the website. And you can also join our mailing list where we're sharing upcoming events, recorded sessions, as well as our weekly newsletter that slowly becoming more and more popular, where we're sharing latest blogs from data professionals. And this event is sponsored by Data Driven Technologies nonprofit, and DDT, short of Data Driven Technologies, is the nonprofit that funds this user group, as well as SQL Star in LA event. This session is sponsored by Microsoft in SolarWinds. And you can go ahead and scan that QR code or click on the link below that QR code to participate in T-shirt raffle. We have a few disclaimers. The color of the T-shirt that you see might not be available. You need to reside in US because the shipping is going to be twice the T-shirt. And you need also to be present during the raffle. And during this presentation, please feel free to drop questions in the chat. And either me or Yelena are going to voice it out. And without further ado, let's move to the rockstar of today's online meeting. John, please take it away and introduce yourself.
Sure. Pull that up. All right. Hopefully everyone can see my screen. Steve, thank you for having me. Very excited to be here. One other thing to mention that you missed there, Steve, is the Friday, the June 9th, that there's going to be a pre-con going over performance tuning there. That's an all-day event. So if you've ever been in a scenario where you weren't able to buy vendor tools to help you see what you're supposed to tune, there's going to be a whole day training on how you can find and tune things with only using free tools. So with that, I am John Sterrett. I am one of the founders of the Austin, Texas SQL Server user group. I'm a Microsoft certified trainer. I'm certified in so many different Microsoft things, I stopped counting. And basically, I love SQL Server. So similar to how Steve in LA is having a SQL Saturday in June, we had ours in February. I love basically performance tuning, and I've been lucky enough to spend over 10 years of my career doing what I love to do for a job. Now, I've done that through my company, Procure SQL as well. So if anyone ever has any performance tuning questions, you can always reach out to me via email, Twitter, LinkedIn, or any way that works best for you. So today's goal is pretty simple. I mentioned that I love performance tuning. And one of the things I've seen a lot is that it's very easy to get lost or to start looking at things that aren't helpful when you get started with performance tuning. So I wanted to build a presentation that was geared towards any individual who really doesn't know much about anything about performance tuning. So if you're someone who does performance tuning day in and day out, you may learn a thing or two, but this isn't really the session for you to get a lot of knowledge learning here. This is really geared towards people that are getting started to performance tuning. In fact, my goal is hopefully just to give you at least some processes and tools and skills that can help you identify and solve some common problems here. So here is tonight's agenda. Tonight's agenda here is going to be focusing over three different things. So the biggest mistake I see a lot of people making when they actually get started in performance tuning is to actually find the real root cause of the performance problem. A lot of times we'll have some user come to us and say this query is slow, but it might just be a symptom. It might not be the real problem that you really need to go after here. So we're going to talk about three different tools quickly that you can use to allow you to make sure you're actually focusing on the statement that's causing the most pain for you. After we go through that example, we're going to go ahead and take a look at execution plans. And again, I'm going to make an assumption here that everyone that is attending this is something that's pretty new to you. So we're going to have three main takeaways here of things I want you to focus on whenever you start looking at execution plans. And then here at the end, we're going to wrap things up with a very basic framework that anyone can use. I've actually tried this with my wife, who is a marketing person, doesn't work in IT at all. And even she was able to kind of follow those 12 steps there. So I hope anyone will be able to at least use this framework to kind of build a process that you can follow as you look at getting started with making indexes to improve performance for your top offenders. All right, so I remember way back when I started performance tuning, this is kind of how my intro is. And I talk to a lot of people who do a lot of performance tuning, and they kind of find a similar path here where you may have some metric, for example, CPU, and it's going normal, then all of a sudden it gets all the way to a bad indicator, in our case, 100%, and it causes things to just come to a halt. And so people, users, end up getting frustrated and upset. And that leads to a bunch of people coming over and asking you a bunch of questions that doesn't help you actually get towards tuning the query or making things better. So for example, when I started, I worked for a law firm, and I remember, all kinds of third-party applications built with some of the most weird code I've ever seen, and managers and people from help desk coming over, just standing over my shoulder wondering, is it done yet? Is it done yet? Why is it slow now? So this kind of starting out kind of made it seem like a needle in a haystack, where I'm kind of struggling because of everything that's going on and what everyone's talking to me, to focus on the top offender and to go in and actually look at that. And then another thing that you tend to notice too, especially when you're not looking at the actual root cause of your problem, is you see scenarios similar to the arcade game known as whack-a-mole, where basically you whack one of the moles and you think the problem goes away, and then you see a whole bunch of other pop up because now they're able to consume resources, so they're now a problem. And it kind of seems like this game just keeps going. So if this is a similar experience to anyone, don't worry, it's normal. I think a lot of people have started this way. This is kind of the main reason why I've built this presentation, to hopefully help people who have never done performance tuning to eliminate some of the pain that I see happen all the time. And even me myself, when I was learning, fell to a lot of these problems too. So before we dive into the demos, and there's quite a few different ones here, I want to talk about a few basic things just to kind of make sure we're all on the same page of understanding some of the high level of query performance and how queries run. So anytime you run select star from very big table with no filters or any other query that you would pick to run, time is going to go by until you actually get your results. And so I want to kind of break down that time into 3 different areas because SQL Server is phenomenal at having a feature known as wait statistics that can give you some good insight to what resources are causing you to wait. So I always kind of like to think of walking through this as similar to going to a grocery store, right? We go through, we get all our groceries, we go to the checkout counter. And once you go ahead and get to the front, maybe you realize you forgot something like the milk. So you end up leaving the line, going and getting the milk, and then you have to get back at the end of the line. So that's kind of similar to how SQL Server Engine works, except it happens very, very frequently and lots of times throughout running a query. So for example, I may need CPU. If you're using CPU and you have a thread, it's only going to allow you to stay on there for a very small amount of time. So that way you don't become the bottleneck for everything else. So you get pushed back to the queue and you got to go back through the queue. And this is where we have different states here. So if you are running, then that means that you are continually processing. But if you're suspended, then that means you're in that T1 area where you are not in the queue to run, to be able to run, because you have to go get a resource like memory, disk, CPU. So I just kind of want to make sure here, and that so whenever I refer to wait time or you hear that, that's the whole duration here. And so now that we talked a little bit about how a query goes from start all the way down to actually getting to run, I want to talk a little bit about some of the main bottlenecks here. So most bottlenecks can be broken down into these categories here. And I have memory listed first because whenever someone asks me, hey, I'm running Enterprise Edition of SQL Server. What's the one thing I can do to just try to help make performance better by spending money and buying something? And the answer I usually say is, well, try memory first, because SQL Server is a caching application and it's going to put as many pages as it can in memory. So the more memory, usually the better for you. Now, I mentioned that first because if you have problems with disk and you don't have sufficient enough memory, all you're going to be doing is stressing your disks more, and actually getting some more memory might help you in the long run. We have CPU here, as I mentioned before. Even if you are running, you're only allowed to have a few milliseconds of actual concurrent running time before you're kicked off the queue. This is what SOS schedule yield wait is known for. It just means that you need so much CPU that we're going to let you go back into queue so someone else can run. We also have networking, which is DBA's usually favorite one here, because this, in theory, makes people think that it's a network limitation. But 2 that we're going to go over tonight. One is the hardest, I think, for all intro to tuning people here, which is the locking, blocking, and deadlocks. So we're going to go through that example, and then we're also going to go through an example where I'm going to create CPU pressure, where it's going to go up to 100%. It's going to take a workload about 2 minutes to go from start to finish. And then we're actually going to dive in throughout the rest of the session on tuning that query. At the very end, we'll actually go through an indexing strategy to where we can get that same workload that took 2 minutes to run in about 7 seconds. All right, so when do top offenders matter? So I already talked about one of these use cases where you have a huge performance problem right now. So in that case, there's different sets of tools or scripts I would like to use. So whenever I'm looking at a big problem right now, I'll probably have a monitoring tool or query store or something that's collecting data and doing baselining for us. But as the problem's happening right now, there's a couple of scripts which I'm going to go into that are big in my toolbox that I use to go in quickly and go straight to a root cause of a problem. So we're going to go through that example. We're also going to look at maybe if you wanted to do a root cause analysis. So for example, if you had a performance problem, say on Monday or last week, and you have a time period, how can you go back and actually look and see what could have been the reason for the performance problem? And, that's a great scenario where everyone, if you're on SQL Server 2016 and newer, you might be able to use Query Store to help you with that. A couple other cases here. I work a lot with companies that have very critical processes that run throughout the day, at night, during different intervals. And a lot of times I'll go through exercises where we want to improve that workload. So for example, if we have a data warehouse where we need to load data into the facts table and data is constantly growing, we may want to do some stuff to where we can look at that process and hone in on that to make that better. So that's going to be actually a great use case for us where we're actually going to focus on extended events there. And then the last one, which is one of my favorite ones, which we do a lot here at Procure SQL, is when we help people migrate to the cloud or do upgrades, we try to focus on helping them save on their capital expense for going through and being able to actually tune their workloads to reduce how much compute power is actually needed after they do that migration. And so that's just one case where we can actually go through holistically and look at the whole environment and figure out good ways to consolidate to reduce the core count or compute that is needed. All right, with that, Steve, did we have any questions out there before we jump into the demos?
So far, no questions.
Okay. All righty. All right, so before we get started with the fun demos here, I just want to quickly go over a script I built well over 10 years ago, just to kind of show some history here. So when a performance problem's happening right now, I want to be able to run something that kind of gives me what I would call the who, what, when, where, and why about what's going on right now. And so the way how this is done in real time here is to actually go through what's known as DMVs or dynamic management views. So these were added in SQL Server 2005. And there's a lot of great performance ones that start with DM_exec. So for example, if I wanted to look at every single session and get data about the sessions, I could do that with this view. Now, if I wanted to know the requests that are running through those sessions, I would do it through that one. And then here are some other functions here that just give us some more interesting data. So for example, I could pass in the handle here and actually get the text of the statement that was running here. And this is the same thing for the execution plan. So if we actually go here and look at our results, you're going to see here we have what kind of command, what the session was, what database, who the user is. And then remember here how we talked about the state of the query, where it is in the queue, if it can run or if it's running and what it's waiting on. So here's a case where we have CX packet waits, and I'll move this over a bit. That there to help. So here we can see this one is actually currently able to go. The rest here are waiting on being able, there's an operator that is going parallel, and it has at least one thread that is waiting for other threads to finish here. We can get our exact query in here, the parent group of, so if this is a batch where you got a whole bunch of statements in it, you can get the whole big batch as well. And then kind of the meat and potatoes here, right, is where I would see CPU reads, writes, logical reads, and all that there. So while this is great 10 years ago, there is a script out there that is 100% free for everyone to use that will get you this and a whole lot more. And so this is SP who is active. So before we kick off our workload again here, this is just showing you examples, some of the similar stuff here. How long is something running? Which session is it? What's the last query that ran? What are we waiting on? How much temp DB, CPU? What you're hopefully going to learn today, though, is you can do so much more with SP who's active than I would have ever thought of putting in my script. And so when I'm looking at performance and pain points right now, this is definitely one of the tools that I use a lot here. And so it's built by Atom Mechanic. As I said, you can go to whoisactive.com to get more information. He actually has a great tutorial where I think he did like a 30-day blog series where he will actually show you so many different things you can do. For example, I have some customers that instead of having a monitoring tool, they actually use this periodically to flush data to a table that they can review later as well. So there's all kinds of great stuff that you can do with this. So with that, we're going to go ahead and get started here. So I have a workload here, and real basic, you know, we have our one metric. We're focusing on CPU right now. I'm going to go ahead and run a demo, and if this works, we're going to see CPU is going to instantly spike and hit over 100% and sit there. You see here in the background, this is it doing work there and finally starting to get some results. You see maybe a little bit of a drop here and then back over to 100%. Well, this is where we would use SP who's active as an example to look at a performance issue happening right now. So most people who use this typically use it one or two different ways. One here just without any parameters at all. And you can see here that this is getting us the basic information here that we can go through and look at. The other one here, this doesn't include execution plans here. So you can do the parameter get plans equals 1 here. And this will give you pretty much the same results here, but we'll have another column that has execution plans here. And so pretty cool that you have an easy way to go through and see what's going on and look at the whole. This is an execution plan. If you've never seen one of these, don't worry, we're going to go into this in more detail here. But a lot of the meat and potatoes of everything I would want to know is right here. But my favorite parameter here is actually using help equals 1. And I'm going to get to this here in a little bit because I know I have CPU pressure and I've used this tool quite a bit before. So I know I can actually sort the whole results here based on our CPU in descending order, so the biggest pains will flush out first. So we just finished here. You can see that this whole workload here, if anyone's counting and wants to keep track. So this ran here in about 1 minute and 33 seconds here. I'll kick it off again just so we have that while we're looking around here. But hopefully at the end, we're going to have this whole same workload run and finish in about 7 seconds. So once again, I want this to bake in for a little bit here, and we're going to go ahead and see that CPU spikes. Our CPU is around 100. And so now I can run the same way we did before, but just add another parameter here called sort order. So let's do that. And so what this does for you is it gets you the same results here, but you can see that it's actually ordered in here from greatest to least amount of CPU usage. So if CPU is our pain point, we know that we probably want to start over here.
John?
Yes.
Wouldn't you get the same information with just running who's SP who's active with no parameters at all. I thought that this is sorting by more resources by default, or maybe I'm wrong.
I think it goes by time running, but the main
Got
point,
it. You're
the
right.
main point
By
here
runtime, you're
too,
right.
with sort order, Steve, you can make this be whatever you want, right? So if you have a disk subsystem that has high latency, right, we can switch that over to reads and focus on that. So the main key thing here is if you have a certain resource that you want to focus on, you can easily order this. But my favorite here that I don't want to show here is actually help, because this is where you can dive in and learn to do so many things that you didn't even think was possible. For example, if you wanted to, you could use this to filter the results that's shown to you. So for example, if you had a particular session ID that you wanted to focus on, you can use these filters here to filter based off of that. If you want to show sleeping SPIDs, you can show those as well. Same thing with system in there. You can get the full text. Get execution plan will allow you to get the execution plan. If you want to get more details about the tasks going on for each thread for a query, you can do that there as well. If you have blocking and locking issues, you can get more info about locks here. And my favorite for blocking here is this one, which I'm going to show you in a little bit here. Is actually pretty darn cool, because one of the hardest things working with blocking is actually finding what the root blocker really is that's leading all the blocking, so you can figure out what's causing that query to go slow. So we'll go over that here in a little bit more. If you want to, you can do a delta. So like, for example, it'll collect, wait a period of time, collect again, and get you the difference here. If you want to output this results to a table, there's ways how you can do that and specify the columns that are returned by doing an output column list here. We just talked a little bit about sort time. The default, Steve, so this answers your question here. The default there is the start time in ascending order.
You're right. Yep.
Yeah, all kinds of stuff. Destination table, so if you wanted to dump this to a table, the first thing you would actually do is get the schema that you'd want to create the table and then dump it into it. So all kinds of amazing, great stuff here. So if you go to the pre-con on the 9th of June, we're going to go super deep into this and quite a few other tools as well. But yeah, lots and lots of great stuff here. So we went over, what kind of scripts I would look at for a problem that's in flight right now. Now, let's take a step back and think holistically. If I can't buy a monitoring tool, how can I collect performance data that I can look at in detail later? And one of the things you can do, and it's shocking to me still, how many people that have been using SQL Server 16, 17, 19, 22, and they don't know about Query Store. And so Query Store is a feature that from 16 to 19 would be disabled by default, and you'd have to enable. If you create a new database on 2022, it will enable Query Store by default. But this is basically like the marketing team from Microsoft, I remember, referred to this as the flight recorder. So basically, all the performance metrics that you would probably want, a lot of it is persisted in there. So I want to show you exactly how you can turn that on, and then we'll go ahead and look at some workload that already ran that I captured as well. So this is kind of one of my favorite magic tricks. If you use Management Studio and you see a database here that doesn't have Query Store enabled, you won't see the report folder in here. But I promise here, after we go ahead and enable it, you actually will start to see it. And so if you want to know how to enable it, if you just right click, go to properties for a database, you can also do the alter database syntax there to change this as well. But this is basically how you would turn it on. So the very first thing we'll go look here is you have 3 different options for Query Store. So before 2022, default is off. If you're in Azure SQL, of course, that is also on there. But you have read only and read write. So in order to leverage this here, we'll go ahead and say read write, and now we'll have a bunch more parameters. And so one of the things as a consultant I get asked a lot is how much overhead is the monitoring tool? And the great thing about Query Store is it depends because you're the one who can set the knobs on how often it's collecting. So if you want to collect every minute, that's going to have a lot more of a performance impact on you than if you were just doing deltas, say, every 15 minutes or an hour or so. So Query Store works first kind of similar to the database engine. First, it actually takes some data, it uses memory, and then it flushes from memory to disk. So you have a kind of a similar process here where we have how often we want to collect, and then what interval are we going to flush data to actually be persisted onto disk here. So we got a bunch of different settings. Again, anyone attending the pre-con, we're going to go through this in a lot more detail here. But you got a lot of knobs here that you can go ahead and say how often you want to clean up and purge data out. And one of my favorites, if you're on SQL Server 19, they added a new model here called custom. And so one of kind of the pain points of Query Store when it first started, if you had any very transactional workloads with a lot of ad hoc statements, it would capture every one of those as a different query, kind of blowing up the skew of the data for Query Store. One of the things you can do now is there's knobs here that you can adjust. So for example, you can say it has to run at least 30 times before you start to keep it and persist it. And how long are you going to do the delta to do that comparison for the metrics? And then they have the same thing in here for CPU time as well. So yeah, I had a customer, very transactional system, and they did a lot of table value parameters in their .NET code. So they used memcache to cache a lot of data, and they actually used TVPs to get the IDs and then get the rest that they needed it when they needed it to. And behind the scenes, this was looking all as insert into table variables. So each one of these were literals and different values, and ended up being a big pain where being able to have the custom mode and to be able to have execution count got rid of all that pain that we were seeing with it. So just wanted to point that out. And so I'm sorry, I forgot we did not enable this. So I'm going to do that real quick. We'll just go with the defaults here because I want to show you the magic trick. If you go back here now and hit refresh, this is my magic trick for the evening. We now have Query Store here. So I prefer to dive deep into the queries when I'm working with Query Store, but I did want to show everyone, especially if you're getting started, that if you enable it, you have this great folder here, which will have a bunch of built-in reports that can help you. So for example, I got another database that we're working with tonight that already had this enabled. And the one report most people will use the most is top resource consuming queries. So I'm going to double click that here, and this is going to load a window here showing us all of our statements here. So if you want, you can go to configure, and this will show you all of the different things that you could choose to order on. So just like I did with SP Who's Active, you can tell this to order by something different. So we are having CPU problems tonight, right? So I can switch that here. I can also switch the interval that we are going to look at for the time here. So I'm going to go ahead and do that. And here I'm just going to say last 12 hours. And so here I can see that we have one query that's driving the majority of the CPU here. So this is the one we probably will want to focus on, right? This helps eliminate that needle in the haystack approach here. In fact, you can even look here that we got different execution plans here. And so another really cool thing about Query Store and the reports that I love here is if you click on both of these, we can actually go over here and compare the two plans side by side. So you could go in here and look in detail and go see what's different and why here. So pretty neat stuff through the GUI if you're going to end up using the GUI there. But for me, one of my favorite things here, let me pull it up here, is actually diving through the queries for this here. So within Query Store, you have intervals of when you're collecting. So for the lab here, I think I have it going every 10 minutes, just because I want to make sure I have good data for us. But we can go look to see the start and end time. Here's their DMV that we would go through for stats intervals. And so this will tell you, it kind of breaks it almost like a data warehouse where we have an integer value for a start and end time here of different time segments that are actually meat and potatoes, the reads, the writes, the CPU, the duration. All that's going to be between here, and in that kind of fact-like table, you would just have the ID for the interval in there. But one of the things you probably would want to do is find some top offenders. And again, one thing I will warn, and I do notice, is once you have quite a bit of data, the reports can take quite a bit of a long time for them to render fully and run. That's one of the many reasons why I love actually just going straight through the DMVs here. So for example, what I just did here was I just went through the DMVs to say, give me the statements or grouped by query hash. So we're going to talk a little bit about this too, because there is a difference between a query hash and a query ID that you would see in the system tables of Query Store here. But basically, I took the query hash, which is a unique hash of the text there, and grouped it and ordered by total CPU descending here. So that way I can go ahead and figure out, okay, which statement is causing us the most pain. So here you would add maybe some filters if I wanted to go back in time for a particular time period. I can pick the intervals that were included in that time interval that I want to look at there. And so here I have this query hash that I want to find some more information on. So if I go ahead and declare this, and then we're going to go ahead and look at the two main tables here that describe the data that we're going after inside a Query Store here. And so the first one here is actually, I added a text here, but the rest of this is just the actual Query Store query view here. So there's a query ID. And so I have this example here for a purpose to show everyone, because this is one of those things that can be very confusing. These two are actually the same query. The only difference is there's a space in here. But I just want to show you that the query is going to show as multiple queries. And, you know, every query can have one or many execution plans. So if I just went off plan ID or query ID, this might not give me everything for that actual query. So if we actually go here, right, we see we have our space here, no space there. And if I scroll over here, I just want to point out that we have different query IDs, but if you look at the query hash, the hash is exactly the same. So if you have literals, this will try to replace them and allow you to have the same query hash as well here. So that's why I kind of focus on query hash here, where plans, you get all kinds of great information. So kind of the root of Query Store is a plan ID. A plan ID will be associated to a query ID, which goes to information about the query. But the nice thing with plans here is even if you're doing an upgrade, you can see what version the engine is, what is the compatibility level of the database. So if you see performance drift or skew here, after you change a compatibility mode or do an upgrade, you can go ahead and see the other plan and pin it back. So all kinds of great stuff there. So this is showing you other stuff. For example, we're going parallel. We know we have CPU issues and parallelism going on, how many times we compiled, all kinds of great stuff here. The other nice thing is per plan, or as I like to do it, query hash, I can drive deeper and find those weights that occurred most often during the time interval I want to focus on. And that's what our next part is here. So if I do this here, this took that statement. And remember, we had two different queries and there were multiple plans out there for them all. So if I wanted to, I could have just aggregated all this together, but I wanted to at least show you guys difference by plan. You know, this will give you all the weights here. So we got actual using CPU, and then we actually have parallelism where we have at least one thread or more threads waiting here. Right, it's the same thing here. So if you want to drive deep into, you know, what resources are causing your pain that you want to focus on, you could do that here through Query Store that way. The last little example that I'll leave you here with Query Store is one of many where you could drill deeper. This one's pretty neat. If you actually have your top offenders in Query Store, if you want, you can easily hash through all of them just to see if there are any that have missing index hints inside of the execution plan. So I'm going to go ahead and show that here. Get that, there we go. And so here's an example of two different execution plans. It's actually the same query. And again, this is the one that we're going to focus on here in detail and a little bit later. But this will show you here. And the execution plan, all it really is XML text. So if you know of any particular thing you want to dive for, you can actually go through and get that. And so here's an example. We see a missing index hint here. So the main goal that you're going to see here is this is actually not one that's going to help you at all. But it is there. That's why you want to actually dig deeper into your execution plans, which is what we're going to get to here in a little bit. All right, so we went over those. The last one here is how do you find a top offender for a set process, right? And this is where we're going to use extended events. So extended events is kind of the thing that hopefully in one day will replace profiler and server-side trace here. But I'm going to show you how you can create one and why I know there's kind of, depending who you talk to, there's kind of like a old diehard legacy group of people that just love trace and never want to see trace go. And then there's maybe the newer people that just love extended events. And hopefully I am going to show you in this demo why extended events can be a lot more helpful for you in a lot of cases. So if you never used one before, if you go into management here, you'll see extended events here in your sessions. So here I can go here and do a new session wizard. So if you've never ever created one of these before, this is a good wizard that will kind of walk through and help you on your process of creating one. So we'll give this a name here. We'll say the LA SQL user group here. We even tell this that we want it to start on server startup here. So if we ever reboot the instance, when we restart the instance, this will even turn this extended event on. So if you've never done this before, there's templates here that probably are going to help you, similar to what would be in Profiler. All kinds of great ones here for querying, looking at, but we're going to actually focus on just going straight through without one here. Because if I'm looking for a top offender for a process, I'm going to want to focus on statements that have completed. And one of the first things I love about extended events is I can type here in this box, and you're going to see that it filters out everything that doesn't have completed in it. So that already helps a lot, because here I can go look and see, okay, what are SQL related things that go with completed? So I have a statement inside of an object here. I have a batch, which can be one or many SQL statements ran together. And I have SQL statements completes here. So I can select those events. Now I can do global filters, which is a nice way of saying, what are some extra toppings you would like to add on your pizza here? So for example, maybe I want to know the name of the application. So hopefully if you're building a .NET app, hopefully the connection string will have a unique name for the application that might help you figure out which application might be causing your pain. You can also get the host from where the call came from. You can get database name. When I'm looking at SQL processes and I'm going through tuning, two that I want to always make sure I include are these two. And this will give you the unique hash for the query, and this is the unique hash for the execution plan. And the main reason why is because we're going to group off of these to help us out. So you can get that, you can get the user that connected, all kinds of stuff is in here. Session ID if you want. And then next we go to our filters. So this is where, for example, if I was going to focus on a certain session that's running, or a certain application that's running, or maybe a certain user that gets kicked off to run, I can filter and just get that activity for that. So for example, here, if I go here and say client application name equals my app, the application name and the connection string would have to match this in order for it to catch it. All right, so next, last but not least, here's what are you going to do with this data? Do you want this only to sit in memory for quick looking at right now, or do you want to persist this to disk? You're probably, in most cases, going to want to persist this to disk, and this is where you get to specify what location you want it to go to, what size, and how many files that you want, and if you want to enable rollover. So kind of like the transactional log, ideally, when you get to the end, it will rewrite over the beginning. So all that's there. But let's get to the fun part here. Let's actually dive in and look at some of this data. So let's say I had a process that ran. I'm going to go ahead and we'll just grab one of these here. And I want to slice and dice it so I can figure out, okay, what part of the process caused my CPU pain, for example. So this kind of looks like Profiler if you've ever seen it before, but I'm going to show you where this gets really, really helpful. So I mentioned here that we want to have our query hash. You can right click on any column here and add it to the table here. So I could do those here. I can go ahead and get my logical reads. I can get my CPU time because that's what we're really after, and duration. And then, you know, for fun here, we'll add our statement here, right? So now what I'm going to do, and you'll see this under extended events here, we can go over to grouping now that I've added more stuff to the table here. And I'm actually going to group this by query hash. And you can see instantly right there, it just grouped everything by that unique hash for the text. So the next thing I can do here, because I'm focused on CPU pain, is I can go to aggregation here. And I could say, let's go ahead and get the sum of duration, sum of CPU, sum of logical reads. And here, we're going to say, let's go look at CPU time and do this in descending order here. And so that's going to come back here and take everything. So back 10 years ago or so, I would have a bunch of scripts I would have to run that would go through trace files, pull all the statements out, slice it and dice it. I mean, now you could pretty much do this in, less than, I think, 20 clicks with your mouse here without writing a single line of SQL. So if anyone's wondering, okay, what's our top offender here? That's going to be our wonderful query. Don't worry, we're going to dissect this puppy here in a little bit. Steve, any questions at all about going through the processes there for those top offenders?
No questions, but maybe you can kind of guide which tool would you use. Because again, there's basically many tools in your toolbox. Where would you
Yeah,
find one useful than another?
sure. So yeah, just to kind of reiterate, as I mentioned through the slides here, if I'm honing in on a process or I want to basically filter what I'm collecting, I'm probably going to go to an extended event to capture and persist that to disk. If I'm looking at a performance problem right now happening this second, I'm going to use the scripts like SP who is active and go through to find the top offenders through there. If I'm wanting to look back in time or have a baseline of query runtime statistics, I'm actually going to dive into the query store for those.
Got it. So essentially, real time, SP who is active, and then maybe events, maybe query store.
Yep.
Got it. Okay.
All right, so next here, we're going to go to what I would call the super hard beginning tuning problem, which is locking and blocking here. So I have another demo over here that we'll go through here in a bit, but I just want to set the stage for anyone who's not familiar with blocking and locking here. And so we're going to create a very basic example of this. So I got my block script here, and I have my select on block. So what we're going to do here, very simple, we're going to go ahead and actually update one of our big tables here. We're going to find all the records that are the first of 2007 here, and we're just going to change the quantity count for those. But I'm going to do this in an explicit transaction here. So this means I want to do multiple statements, but treat it all as one. So if anything fails, we roll it all back here. And I'm basically doing this just so it's going to block anything that selects here. So if I go ahead and run this, and I go to my select where I'm going to select those records that I just did an update on, this is going to sit here and wait forever, right? This will never finish until I either commit this or roll this back. So once again, if we're having a problem right now, SP Active is one of my tools I love to use here. If we go ahead and run this, just by default, we're going to see, this is a demo here, so I purposely don't have anything else running to make this as easy as possible to see. All right, if you see this isn't going to be all that hard because you only have two here. You can go look at block session ID here and see that session 78 is being blocked by 76. And so you know that this query here is actually the statement that's the lead blocker in this case. Right, we just walk through this very simple thing here. Now, one thing a lot of people don't realize is the SQL text you see here is actually the last thing that ran. It may not be what's actually really causing the blocking. And I'm going to highlight that here by actually going back to this and running another select. Because I'm inside of this same transaction here, I am allowed to select the data. So I'm going to select this here. Now, our other session that's isolated still is waiting because the other session has not completed that transaction yet. Now, I want to show you, because if I go run this again now, we're going to see that this begin tran that actually is the blocker here isn't going to show up anymore. It's going to show that second select statement we ran. And this is one of the many reasons why blocking can be hard to detect and fully understand here. So here we can see that our select statement now is now the last statement that ran here, and that we have null here. So that's our actually root blocker here, because we only have one query that's being blocked by one other query. And so basically now what I'm going to do is I'm going to do this exact same thing that we just did, except I'm going to throw some massive scale at it. So you're going to see so much stuff here, you're going to get lost and not have an idea of what you should really focus on here. And then I'm going to show you how you can weed through that data to make it easier for you to find the root blocker here as well. All right, so I'm going to go ahead now. You can see this guy is still going, is going to go until this guy finishes. The second I roll this back, you'll see the other one will finish. And that's because the only reason why this was prevented was because it was trying to select data that was blocked there. So let's throw some scale here. Let's go back over to our other demo here. And if I go back over to SB Who's Active here and run this a few times, there we go. We got something that looks a lot different. And we can keep changing this. So now when you actually have a realistic load or a lot of blocking going that's chained, right? We have our weights here. So if you see LCK, that means locking is happening here. But it gets real complicated when you got to look at, okay, this is 71, it's blocked by 80. What's 80? 80's over here, it's blocked by 75. Where, like, this gets hard and a lot of people kind of stop. But one of the many features in SB Who's Active is actually being able to dive in and actually go find what your lead blocker is. So here I added find lead blockers, and I enabled it by default, that's disabled. And I said, let's sort by blocking session count. So we'll see we have this new column over here. And we have null here, and we have 10 here. So we have this one that blocks the most. So this is your root guy here. So for the demo here purposes, I put a wait delay in there just to force it to bounce between the select and update to enhance the blocking there. But this is something that a lot of people who even use SB Active don't know that they can do. With just a couple parameters, you can easily get to that root blocker there. All right. All right, so we went through a lot of great examples there. Let's pop back over to the deck for a second here, because I want to talk about execution plans, and I want to try to do this at a very basic level. I love to travel. I'm looking forward to being in LA in June for the SQL Saturday here in about 3 weeks. But I'm also a huge fan of all Pittsburgh sport teams. So I like to fly a lot to Pittsburgh. And so I live in Austin. And unfortunately, United, which is my favorite airline of choice, does not have any direct flights to Pittsburgh. So I have to stop somewhere here. So ideally, I might want to stop to Houston, have a short delay, and then go straight off to Pittsburgh. So in a way, this is similar to execution plans that you're going to see in a few moments here. Think of a hub here as an operator, and I'm going to show you what operators are here in a little bit if you've never seen one before. But basically, a lot of segments that go from start to finish in your plan. And so SQL Server's goal in the database engine is to find a good enough plan quickly. So it's never going to look for your shortest duration flight plan, because it would take forever to traverse through every single option it can come up with. So for example, I have a friend who loves making sure he has the highest status on United. And one of the conditions is segments there. So if he was doing the same trip, you know, he may actually want to, let me go back. Take my pen here. He may actually want to say, go through LA, go through Seattle, go through Chicago, and then head to Pittsburgh. So 1, 2, 3, 4. So more stops, more operators, may be good enough for him, but probably not ideal for someone who wants to get there quickly. And so this is kind of the same thing with SQL Server. The goal is to try to get a plan that gets you your data as quick as possible. So with that, let's go ahead and go over and look at an execution plan. So here are your set of options here. Oop, pull that there, magnifying glass. So every one of these here, this is a different operator. If you're not familiar with a lot of these operators, we're going to start very simple. Whenever you see index scan, that means it's reading all the data for that whole index. You might return only one row or need one row, but it's still going to read it all. So in this case, we have a clustered index. So we're telling SQL Server the order we want to persist this data to disk for the table. And it's going to scan through that whole table here. Right? If you see these little arrows, that means we're going parallel. That means multiple threads can be used. The first thing I want to point out, though, is that if you're just starting to look at an execution plan, is to follow the thick lines. I'm going to go back over here and zoom in, because notice how this line here is much thicker than all these little ones here. And it kind of makes sense when you look at, so it tries to break down and come up with a cost estimate for each operator. And obviously the one at the end of all these big, fat, thick lines has the big cost there. So your goal is to try to get to the operator that is doing the most CPU, because we're focusing on CPU here, and find ways to reduce that pain here. So following the thick lines is something that will be helpful for you. Another one here that we want to focus on, especially when we get to our indexing demo, which we're about to next, is what's known as a key lookup or a bookmark key lookup. And what this means is we have a filter that is perfect, right? Let's say we have a people table and we have first name, last name, middle name as different columns, right? And we want to filter through and get all of the last names for all the people who have a last name of Sterrett. Well, we could go through and seek and get that, but if our query has select first name and middle name, well, it's going to have to go back to the heap or clustered index to be able to select those columns that weren't included on the index. So I just want to point that out. Whenever you see a key lookup, this means that we could have potentially maybe included something on your seek here that would allow you to just do the seek and not have to go back and get the extra columns there as part of that. All right. And the last one here, just to point out, kind of highlight here as a good one here, is if you see exclamation points in a plan, you probably want to highlight over it so you can get some more details. And I did that here just to show you one of them. So this is what's known as an implicit conversion. And it's going to basically show you that you have two different data types on top of a comparison that don't match. So one of them has to be converted, and this might cause you to have to scan and read all the data there. So we got that. And so with that here, we're going to go ahead and talk a little bit about an index pattern you can use if you have never ever done any indexing with SQL Server to help with performance. Now, as I mentioned in the beginning, I've actually walked through this with my wife, who is not an IT person, knows very little about SQL Server, but was able to follow this pattern of steps here. And so one of the things most people, when they get started with performance tuning, is they just run the query and start looking at things and then start changing stuff. Well, you're going to see we don't run the query at all until we get to step 7 here, because we're going to start with the pure basics of first things first. I'll try to simplify this as much as possible. We're just going to identify, okay, what tables are used in this query, right? Because that way we know all the other tables in the database we don't have to worry about, because we're focusing on this top offender that we found through using the query store or using SB Who's Active or using the extended event trace. We know which query to focus on. So now let's just focus on the tables in that query. The second part here is what columns are being selected. So remember, I just talked about the key lookup example there. Here we're driving deeper into that here. So we're going to make sure that we focus on what columns are selected as part of that, so we can make sure if we do any indexes, we try to include those if we can. The third part here is how are we filtering our data? So inside of our where or join condition, this is going to show us cases where we're going to return or use less than the full table of data. So we just want to identify what these filters are, okay? So that's what I call my research starting point there. If you don't know anything about SQL Server, hopefully after I walk you through this example, you'll definitely be able to do those things there. The next step here is we're going to go figure out, okay, how many rows are in this table? Because if we're going to do any index changes, we don't want to focus on tables that have small amount of records in them because your index isn't going to avoid a whole bunch. You want to find tables with millions and millions of records. So that way, if you could filter down for your index where it only needs, 10 or so, you could filter a lot of data instead of scanning across that whole table. So the next part here is look at the selectivity here. So this is actually going to look at the rows with the filter and divide it by the count of rows in the table. So the whole goal here is the one that has the least amount of rows does the most filtering. That's going to give us our best improvement for tuning. And so we're going to go through an example and show that there to you. So after I've done that, okay, I have an idea in my mind of what index I want to start looking at. But before I do, I want to get a baseline. So I'm going to enable statistics, IO, and time, which are metrics you can use when you run a query that will actually let us know how much CPU, how much time, how much logical reads each table in that query did. And I'm going to document this. So I have my starting point if I know exactly how long it took and how many logical pages were returned for a table there. Then I'm going to go ahead and implement my indexes after I review what existing indexes already exist. Maybe you just need to add something to an index that's already there. So we're going to go through that. Then I'm going to add that first index that I found from my research here by looking at lowest selectivity. And I'm going to run the query again and document my findings and compare that back to what I had at step 7 and see if this is good enough for us. If it's not, then I want to go back up here and look at some of those other filters and identify selectivity and try some other indexes as well. So I know that's quite a bit here, but the last part here is a demo where we're actually going to walk through this process. So I got my indexing example here. And so here is that query that we've pointed out. We looked at the execution plan. We've seen this pop up as a top offender for CPU pain. This may look to someone who's new to looking at queries and performance. This may look like a lot of stuff going on here, but we're going to simplify that by using our process. So the first thing I had there, step 1, is what tables? Well, if you go to your from clause here and you see all your joins here, this is going to show you the tables. So we have dim product, dim date, fax online sales, dim store here. All right, so we have those tables here. So the next thing we're going to do is look and see which columns are being selected. So if you go to your select part here, we'll see that we have these two, and we have these two inside of the sum here. So we would need these 4. So we have those there. Now, next, we're going to look at our filters. And so our filters are going to be where our where condition and statements are, but also where we're joining our tables together. So here we're going to see these here. So an example, product name is like Contoso Mouse Lock Bundle here, or our calendar year is greater in 2007. So we have these 3, but then we also have these 3 in here for our table joins as well. All right. So now that we have that, that's kind of our documenting, what tables are we using? What columns are we selecting? What are the filters on those tables? That's going to reduce us from hopefully having to look at the whole entire table. So the next thing here is to actually get your count here. So I'll go ahead and run these here. But you could do select count to get your count here. And the biggest thing to look here is if we do indexing on dim store, we're not going to really get much help because there's only 306 rows there. But if we focus on our facts online sales here, we got a huge magnitude more rows here. We got 12 million rows here compared to the others, which are just 2,000 or 300 here. So from this step here, we already know, okay, we want to focus on this fact online sales here. So this is where we're going to look at the selectivity. And here's just getting the count of how many rows would be used for each filter that we have here. And so if we go by this product name here, we only have 4,000. So from here, this means that we would only need 4,000 of the 12 million rows here. So we're going to start here by making sure that we filter off of the column here that's used to join us into this, which would actually be our product here, our product key. All right. So we kind of have an idea of what column we want to use for an index. Let's go ahead and actually look at what indexes we have. So if you hold Alt, hit F2, it's the same thing as running SP help, which if you run this on a table, it's going to give you the table, columns, and then indexes here. So we only have one clustered index, and it's on online sales key. Is this index one of our filters? Well, if you don't know or you forgot, you could just scroll back up to here and look and see, and no, it's not. So we're going to want to create our index here with our product key. Another thing I just want to point out here is if you want to get magnitudes of information about indexes, there's another set of community scripts created by Brent Ozar and his team way back when he had a team that did a lot of great consulting work, SP Blitz Index here. So if you were to run this, you'll see you're going to get a lot more information than what you saw with SP Help here too. So just to kind of show you another tool that you can use. For example, how many times has it been read versus write? So you have usage statistics. You have the size here if you want to know how much space an index is using, what type of compression. You know, ever since SQL Server 2016 SP1, compression was added to standard edition. So if you have standard edition even, you should be using some type of compression. How long are you locking? All kinds of stuff in here that you would want to know. And then same thing here through columns, any missing index recommendations, all your foreign keys. Basically, probably more than you would ever want to know you can get here. But our main purpose here was to see we don't have an index here, right? If I scroll back up on product key. So we can go ahead and create that one. But first things first, we would actually run this statement here, which I already did. And just to show you, you could turn on your set statistics time in IO by just typing the text. Or if you also really wanted to, if you didn't want to type it, you can right click in Management Studio and go to Query Options, Advanced, and then you'll see the two options here. So either or, same thing. And then if you want to get your execution plan here, you can select this to get to see that as well. So I'm going to go ahead and run this. And it'll take a few seconds. And so to benchmark here, we're going to look at two different things. One, the Messages tab. And so again, from our research, we know that this is where the lion's share of the work's going to be here. And as we expect, this is where most of our logical page reads are. So we got 47,310. Right? Our goal is to reduce that. And also, if I scroll down here, try to reduce our CPU time. And so one thing you might be wondering is, John, this only took 950 milliseconds to complete. Why do we have more CPU time? And that's a great question. The reason why is because we have multiple operators that are working in threads in parallel together at the same time. And so we'll see that when we look at our execution plan. So this is our first execution plan. And just like we saw in the slides, follow the big thick lines first here. So for example, if I hover this one here, that back here, we only have 2, right? We're going to see these big thick lines here be way more. And so here, right, we're scanning here. So we're reading that whole big massive 12 million row table, even though we really only want to suck out around 4,000 rows out of that. So here we have that, and we have those there. So now we can go ahead, create our index, and see how things change. So here I'm going to create the index. This will take a few seconds. And while we're waiting here, I'm going to already show you the results here. So we had 42,000. This is actually going to go down to 13 here. And so we have that. If we run this again, so notice the CPU time, we got this down to 32 milliseconds. And if we go over through our thick lines again and go over here, raise this up. So we see an improvement here. So instead of doing that scan here, we're doing what you see is a seek. And this means we're going straight through the tree here to get the data that we need. And this is why our cost is so low. But remember, everything is going to come in through our nested loop. So this is a fancy way of saying a for each. For every row here, do what's down here. And this is where we would have our red key lookup. You see 99% of the cost here because we're actually going to get those columns. Remember, we wrote down what columns we selected from the tables? Well, we didn't include those in our index, which is why we're coming down here. So even though we improved our reads by 1/4, we could do better here. And so this is where you'd go back, you'd see the columns here that we're selecting for that table. And if we include those in here and redo this, we are going to see this be greatly improved. And so here again, I'll show you the results. Remember, we started with 42,000. We're actually going to get this down here to 24. So if we actually run this bad boy, it'll go instantly. There's our 24 reads. And then same thing down there. And so 2 things here to point out. One, we have our index seek here. So we're seeking, we're getting everything here. We have no other operator with this fact online sales table. Good. We reduced our I/O, our reads from 42,000 and our CPU all the way down as well. But the one thing I want to show here is we have a missing index hint. And so a lot of people, what they'll do is they'll see this and they'll just instantly use it and build it and create it. And this is where you get so many indexes that actually hurt you more than help you. Because if we go back and we look at our homework that we did, we see this is on dim product. How many rows are in dim product without any filtering? 2,000. We're not going to get any real gains here for this. And the fun thing about this demo is this will go through every one of these tables and do the same thing here. So it'll do this one next because it's the next biggest, and this one where you're not going to get any benefits here. But going through this process, you're going to know that and build that pattern up there.
John?
Yes.
If you can go back to the previous slide, I guess to the previous tab.
Slide?
No, slide, my bad. Tab. SSMS tab.
Mm-hmm.
The one that was showing missing index.
Oh, that was just. Oh, okay. Here. Yes.
Yes. Any reason why it's actually not showing percentage? It's showing impact, but I think it's usually showing percentage.
No, impact is known of a way of internally putting metrics of weight behind
Got it.
how many times it would run versus cost of everything else on the whole plan as well.
Got it. For some reason, I remember percentage. Okay, never mind. Maybe it's just me.
Yep, no worries there. But yeah, so that's the pattern here. And this is, if you follow the framework, it'll prevent you from doing a bunch of extra stuff that will hurt you more than help you in the long run.
Is it safe to say that anything below 50% is probably not worth the effort?
So the question was, if anything below 50%, is it not worth the effort? And I assume you're talking about cost.
So let's say missing index and it's showing impact of 15. If it's less than 50, maybe it's not worth the effort. I mean, I know it's like
Okay.
coming
You're
up
focusing
with
on
golden rules, but yeah.
You're focusing on the impact there for the missing index.
Yeah.
Got it. Okay. Maybe it really depends. So once again, the goal is, what are you trying to achieve here, right? Are you trying to eliminate a pain like we have with CPU? Knowing our data and knowing how much data is in the tables in our filtering, we know that this isn't going to help us, right? This doesn't matter because all the work in this query that is our pain point is coming off this table. So this is where we want to try to make sure we have the best seek possible that we can for our query here. All right, so let me pull this up. Any other questions though?
Can I ask a random index question?
Absolutely.
Fill factor. At what point is it appropriate to start lowering the fill factor? I'm just wondering if, because I'm seeing a lot of fragmentation and like occurring very quickly. So I'm wondering
Gotcha. So
like,
fill factor and index maintenance. So this is one where your fill factor will allow you to set certain amount of space free in the pages. So that way you have extra space there to prevent page splits here. This to me was a way much bigger pain point back when everyone was using spinning disks with super fast SSDs. Honestly, I don't worry about that nearly as much as in the past as something that I see for impacting your set statistics. It tends to be, especially when you're working with huge volumes of data, seems to be a lot more important for you than actually going through and rebuilding, trying to save some space or trying to give some free space for page splits.
okay, thanks.
Yeah, a lot of people have different opinions. I know Brent kind of has a similar one where I think he's wrote something a long time ago about not caring about index fragmentation anymore. But I could tell you with a lot of my customers that have terabytes and terabytes of data, we do a lot less. We really don't do much with index rebuilds. It's all about making sure you have good statistics there for the indexes you have.
We get a lot of fragmentation, and we could like rebuild statistics, at 10 a.m. and by noon we have 80% or 90% fragmentation. And I'm trying to figure out like how to deal with that or prevent it.
Gotcha. Yeah, a little bit off topic here. But I mean, it really depends, right? Like if you have a GUID, for example, you can run a query that, updates all the GUIDs, and that would one single query would instantly fragment the whole entire index. So it's, yeah, definitely something to dive deeper into, but not a real big part of the session here.
Okay, got it. Thank you.
That being said, what would you recommend for fill factor? The 0-100?
Yeah, because I want the least amount of pages there. I want to have the least amount of pages.
Okay. I guess this is also probably a problematic topic as well. How much of the shrinking of a database might cause fragmentation?
Not sure I understand the question there, Steve.
Shrinking a database, how much of that affects index fragmentation?
So one, we're going kind of way off topic here. But for shrinking a database, yeah, that will fragment indexes. So there's a big difference between shrinking transactional log file versus shrinking data files. And if you shrink data files, then that tends to fragment the indexes through that process.
Got it. Thank you.
All righty. Well, just to recap here, these are some of the tools that we used here. The first two, SB Who is Active, is a community script that uses DMVs, dynamic management views, and same thing with SB Blitz Index that you can get. Query Store and Extended Events, these are actually tools given to you by Microsoft as part of using SQL Server that you can use as well. And so again, anyone watching the video, if you have questions, want to reach out, need some help with performance, feel free to reach out. You can shoot me an email at John@Procure SQL, or you can leave a comment on my blog or hit me up on Twitter as well. And with that, Steve, I will turn it back over to you.
Thank you. That was quite a lot of info and super helpful.
Good.
Any other tools would you recommend?
Yeah, there's quite a few of them that we're going to go through in your pre-con here coming up. So Plan Explorer is another big one when I dive real deep into execution plans that I love using. And then we have a whole bunch of tools for generating workloads or stressing an environment as well. So one of the ones I kind of used real quickly here was RML utilities here to actually use OStress to run stress, but we'll talk through some of those as well. And even there's some tools that you can use if you don't have anything for benchmarking your environment that you could do through Perfmon as well to build some nice reports and also give you some good insight there towards what the metrics mean and what you should be looking for.
Got it. Cool. Thank you. Okay. This session is recorded and I will publish to YouTube and Rumble once it's all published. Thank you everyone for joining our online meeting today. With that, thank you. Have a great day and see you next meeting. Thank you. Bye-bye.
Thank you.
Thanks, everyone.
Yep.
Thanks, John.
You're welcome.
Thank you. Have a good night.
Thank you.
Bye-bye.
Bye.